And for log functions, the technical word is logarithmic, but that's a mouthful when you start talking about everything that's here. So we're just going to say log for short. And when we talk about log functions, basically here's the big thing you have to know is that log functions are inverses of exponential functions. Okay, and if you get down to what the basics are for inverses, remember that for inverses, when you look at it in its basic form, is that you're going to switch your x and your y variables. Now, if we start finding equations, we do other things with it, but technically, to find the inverses, that's where you're just going to switch x's and y. That's the reverse operation. So again, for us, what we're going to do is we're going to switch x's and y's. So when we talk about log functions or log equations, again, they can kind of go two different ways, and you'll have to kind of interchange between these two. So if you talk about a log equation, it's y equals log base b of x, or you can say log of x base b. And yes, that b is actually like underneath, like if log x is here, the b is actually kind of underneath it there. If you talk about a log function, because sometimes they may give you a function, and if you do, you're pretty much going to turn around and rewrite it back as an equation, because then we can find the inverses of it. But if it's a function, again, you're just taking out the y, you're going to replace it with f of x. But again, if they give you a function, you're almost always going to turn around and rewrite it as an equation, because we're going to wind up switching the x and y variables as we go through these. Okay, so when we're talking about those two things, b is always the base. Okay, and to write an exponential equation, in log form, you basically just add the word log and then you switch x and y. Again, that being the inverse part of it that's there. The one thing is, whenever you're working in logs and exponentials as you go through these, the base always stays the same. Okay. And probably a lot of what we're going to do today is we're going to do a lot of just rewriting it back and forth so that you're okay moving from logs to exponentials or exponentials to logs. And once you're okay with that, we'll actually do more stuff with this tomorrow. So today's just one of those days where we're going to get comfortable with kind of working back and forth. And then tomorrow we'll actually start doing a little bit more application with these. Okay, so the very first thing we're going to do is going to go back to what we had yesterday with stuff written in exponential form, and then we're going to rewrite it in log form. Okay, and we'll start with just a basic generic. There's no numbers on this thing, or just our base is b, and we've got an x and y there. So. Okay, so when you're going to rewrite these, again, the one thing you're going to do is you're going to add in the word log, and whatever the base is that's here, that base will go there. And then basically you switch the x and y. Like this is going to have like this like b to the x power. So now it's not technically that, but when you put it in log form, it's going to be, instead of being b to the x power, it's going to like b to the y power. But it's not really that way. It's still log of y base b. And the y was by itself. Now the x is by itself. All right, so let's give you one with some numbers. Let's do 6 to the x power equals 36. Okay, you've got to rewrite it in log form. Of course, you got to have the word log in there. And again, the base is 6 to the x power, so the 6 will stay on the bottom because it's the base. And then the other two numbers, you're just going to switch these two numbers. The 36 will go over here, and then the x will go over there. Okay. And for some of the ones we're going to practice on in the beginning, you're not going to solve everything here in the beginning. It's just going to tell you, all right, just rewrite it. And then tomorrow, maybe even towards the end of the day, we're going to rewrite it and then solve a few things just so you can kind of see what's happening with it. Let's see. Let's change some. Let's do x to the fourth equals 81. Okay, so this time your base is x. So again, that will stay here. And then your other two numbers, you just switch it. The 81 will go here, and then the 4 goes there. Okay. And some of the numbers that they'll give to you to practice on, there won't be any variables at all. I mean, we looked at like the very first example had all variables. This one, you won't have any variables. It's just 13 squared equals 169. So again, you've got your log. The base is 13, so that would go there. And again, just switch these two numbers, and we'll put it there. Okay, and then one more, and then we'll go the other direction. Okay, so we've got the log. Now, if they switch the numbers around, in this case, 3 is your base, so now it's 3 to the 0 power. So the 3 would go here, and again, we'll switch these two numbers. Instead of the 0 being attached to the 3, now the 1 is attached to the 3, and the 0 would be by itself. And some people kind of get in the habit. They're like, well, if we've got it written like this, could we turn around and rewrite it so it's like this? If that helps you to kind of see, if you get stuck if you're in a rhythm and you're kind of doing it that way, you can always take this and just rewrite it so it looks like this to kind of make it work out. But the main thing is, again, whatever your base is that's here, and then you switch your other two numbers. That's the main thing that you have there. And again, switching it being that, the 0 exponent is attached to the 3. So when you switch it, then again, these two have got to be so that now the 1 is here and the 0 is by itself. Okay, so there's rewriting something in exponential and putting it in log form. Now we're going to go reverse. We're going to give you something that's in log form and then rewrite it in exponential form. And again, just hang on to that, because right now with the rewriting part, we're not going to do a lot with that. We'll actually do more solving with it tomorrow. Okay, so we have log of 25 base 5 equals x, or some people say it's log base 5 of 25. You can kind of say it either way. Somebody says it a little bit different when you go through those. But again, this part, we're not asking you to solve it, which is probably what we'll do tomorrow. We'll do a little bit more solving when we go through these. But in this case, we're just going to rewrite it. So to rewrite it, basically is this. You get rid of the word log, and then you've got basically this is kind of where it's easier. The base stays the same. You just switch these two numbers. So it becomes 5 to the x equals 25. So to rewrite it in exponential, again, take out the word log and then just switch. The base will stay the same, and then just switch these two numbers, and that's it. So if you got log of 2 base x equals 4, again, the base will stay the same, and just switch these two numbers. All right, now we have to throw this one at you. You have log of x equals 2. Okay, so if you get one like this and you're like, hey, what's the base? Where's it going to be? If they do not give you a base, so if no base is given, then the base equals 10. Okay, so 10 is your default base on these. Just kind of like if you did exponents, if it was x to the first power, you don't have to write x to the first power. You can just write x. Same thing with these. If you know that your base is 10, you can just write log of x, and that way you're going to basically just understood that you have it there. So basically, if you have this one, which a lot of times you'll see something like that, that one you just have to know that in that case your base would be 10. So then to rewrite it, again, 10 will stay the same, and you'll just switch these two numbers up, so you get 10 squared equals x. Okay, and that's if you want a preview of what we're doing with this, that's where we're going to go. Is that in the coming up for next part, and why we do this rewriting stuff, is that if we have an equation like this and we don't know what this answer is in log form, we can rewrite it in exponential, and then we go, oh, well, that's 10 squared equals x. Well, 10 squared equals 100. So then x equals 100. And that's where we're kind of going with. Now, again, if it just says rewrite it, we're going to stop here. But just to kind of give you an idea of where we're going with this, when we're after basically tomorrow, after we write these problems, then we're going to turn around and solve it. And some of the problems will be just that easy that you go, oh, well, that's 10 squared equals x. 10 squared is 100. So my answer is 100. Okay, and then the last thing we need to do, and we'll just do a couple of these, and then we'll wrap this thing up. We are going to do graphs of logs functions. Okay, and then what I'm going to do, before we actually show you those, let me kind of flash back to what we were doing yesterday. That yesterday we were doing exponential graphs. And when we did exponential graphs, okay, so before we get to that part of it, we're going to go back to what we're doing yesterday. If we're doing exponential functions, we said if you did just a basic exponential function, this was going to cross over at 0, 1. And you don't have to write this. I just want to show it to you. And it looks something like this. Where we're doing, y equals b to the x power, where, again, your base was some positive number for this one. if it's log functions, we said logs are inverses. So instead of going through 0, 1, guess which point we're going to go through now? I'm going to go through 1, 0. And instead of getting really close to the x-axis in the negative direction, now we're going to get really close to the y-axis in the negative direction. And instead of going up kind of parallel to the y-axis, now we're going to go up and parallel to the x-axis. So all we're doing is we're taking this graph that we had yesterday that was here. I can't get my fingers there. Basically, it was over here on this part. We're going to roll it so it's over here now. Okay, so this was exponential. So that's your log graph. Okay, now the one thing is with this one again, is that we're still going to use this one if our base is greater than 1, as we're going through this part of it. Oh, now, and thinking about domain and range. Yesterday we said that when we did domain and range for this equation, domain was negative infinity to infinity, and that would never change. The range, we said that one would change depending on the numbers you plugged in, but basically we started at 0 to infinity. Since we switched the x's and the y's, when we get to this part down here, we're just going to switch these values. Now the range is negative infinity to infinity, and your domain is going to be 0 to infinity. So again, if this is your x values and your y values, and we switched them to get the inverse, then domain and range, same thing. We're just going to switch these values. So now we're talking about x is greater than 0, and this negative infinity to infinity never changes. That by definition for log functions, you will always have that it's always going to be infinity to infinity when we're going through those parts. The only thing that's going to change is the domain, the numbers we can plug in. Okay, so let me give you one example of what this would look like. And again, we're not going to have like tons and tons and tons of graphs. Mostly it's going to be just basic graphs on these. Let me give you one graph to look at, and then that should wrap us up for today. So let's graph y equals log of x minus 5 plus 3 base 2, or log base 2 of x minus 5 plus 3. Okay, and just like we were doing yesterday, if this was just log of x base 2, it would basically be that graph where we would start at 1, 0. But now we're going to take this graph and move it up, down, left, right. So again, it's still the same thing. The 5 on the inside is still your opposite horizontal movement. So what looks like 5 to the left is actually 5 to the right. Your plus 3 at the end, that's your up and down, so it's going to be 3 up. So we're going to take this graph that we have that's here, and we're going to move it 5 to the right and then 3 up to get our new graph we're going to do. Okay, and again, I'm just going to put this in here just so we can kind of see what we're doing. So there's the original log graph that would start here. But again, now we're going to take this log graph we've got and we're going to move it 5 spaces to the right. 1, 2, 3, 4, 5. Then up 1, 2, 3. So that's going to put that graph here. And again, it's the exact same graph, but now it's just going to go something like this. So again, took this same graph that was here and just moved it over 5 and up 3. So it's the exact same graph. We've just scooted it up and over. Okay. And again, something that we'll talk about with how this is set up and where we're going is that the original graph when we were doing kind of backing up to this one, that 0 was the cutoff line. Yesterday we talked about that we had an asymptote, and again we'll talk about that more coming up. Is that basically this is your cutoff line that you cannot go past this point? That's an asymptote that's here for this one. So basically, we took this whole graph that was here and moved it over 5 spaces. So now instead of the cutoff line being at 0, now your cutoff line is at 5. So basically, there's an imaginary cutoff line that's here that says, all right, you cannot go past this point on the graph. But now you've got a vertical asymptote if you're going through this one. Okay, and then domain and range. Okay, the easy one for this one is your range is negative infinity to infinity. You can go as high as you want to go. You can go as low as you want to go. Okay, but again, as far as to the left as you can go is this cutoff line right here that's at 5. So we're going to go from 5, and then we'll go out to infinity.